Hello, you guys. Now I'm going to go back and finish 12.5, okay? So turn in your note-taking guide to the parts where we said wait, all right? And I'll catch up with you in just a second. Okay, so you should be with me right here at this example 3, letter B, part 2. All right, it was a to the 6th power raised to the negative 2 power. So remember, the trick when circle the 6 and the negative 2 and part of the parentheses. So it's copy the base, a, and then to the power of 6 times negative 2. Well, that would be a to the negative 12th power. Well, now you know what to do when the baby's crying. Remember, we draw a diving board, put a 1 in the pool. Now, carefully circle the negative 12 and the base of a and let them climb down into the pool. So, look over here. It would give us 1 over a to the positive 12th power. Okay, so look at example 4, using properties of exponents. You can cross out the word wait. We're going to do it right now. It said that the side lengths of a square microchip are each 2.5 times 10 to the negative 4th meters. What is the approximate area of the microchip? Remember, to find the area, we're going to use the formula area equals side to the 2nd power. So one side times the same side. So we get 2.5 times 10 to the negative 4th power, all to the 2nd power. So now remember, you would circle the little power of 2 and give it to the 2.5, and you have to give it to the 10 to the negative 4th power. So I wrote it right here, 2.5 squared times 10 to the negative 4th squared. Well, 2.5 squared would be 2.5 times 2.5. And remember, we could use that trick when we're squaring numbers that end in 5. That would give us 6.25. Or you could work it out over here in the margin if you don't remember. And then circle the negative 4 and the 2. So bring down the base of 10. And then it's negative 4 times 2, which would give us negative 8. So it's 6.25 times 10 to the negative 8th power. And that's what the area would be, 6.25 times 10 to the negative 8th square meters. Okay, so take a look right here at the part 2 arrow. Look at number 6. V to the 6th power raised to the negative 5th power. So I copied the base of V, and then with my red I circled the 6 and the negative 5. So 6 times negative 5 would give me negative 30. Well, if I have V to the negative 30 power, I'm going to make that little exponent happy. So I draw a fraction bar, put a 1 in the pool, circle the negative 30 and the V, and let them climb into the pool. So this gives us 1 over V to the 30th power. And then take a look at number 7. You can cross out the word wait here. So it's 5.4 times 10 to the 6th power squared. So we'll write it out. 5.4 times 10 to the 6th times 5.4 times 10 to the 6th power. Okay, grab the front numbers. So 5.4 times 5.4, I did that right here. That gave me 29.16 times, and then since the bases match, I copied the base of 10 and then add the exponent, 6 plus 6. So that would be 29.16 times 10 to the 12th power. Well, here's the problem. This is not in scientific notation because 29.16 is too big. Remember, this front number has to be between 1 and $9.99, okay? So it's too big. But here's what it's saying. See, this is asking you to grab the decimal where it's at and move it 12 places to the right. Well, I don't want it there. I want it between the 2 and the 9. So wouldn't it just be 1 plus 12 to get it to the end of the number? So that means it would be 2.916 times 10 to the 13th power. And again, if you don't understand what I just said, I would write it out in standard form right here in the margin. So grab the decimal and move it 12 places to the right, and then write it in scientific notation. But you would get 2.916 times 10 to the 13th power. Okay, take a look at number 8. I have 1.6 times 10 to the negative 8th power, all to the 4th power. So I circled the 4, the power of 4, and I gave it to the 1.6, and I gave it to the 10 to the negative 8th power. So 1.6 to the 4th power times 10 to the negative 8 to the 4th power. So I multiplied this out and got 6.5536 as my number in front, and that's fine because it's between $1 and $9.99. And then I just multiplied the powers here, so I brought down the 10. Negative 8 times 4 gave me negative 32.